When I have the sine of negative theta, this is a handy identity to know. This is equal to negative sine of theta. When I have the cosine of negative theta, that is the same as just cosine of theta. Well, I'm going to do a brief segue here. I want you to understand through some graphs. I'm going to draw this out. I want you to understand why this is true. So if I say theta for this one, theta equals pi over 4, what's the sine of pi over 4? That's square root of 2 over 2. Okay? If I do theta this way, where theta equals negative pi over 4, so I'm going clockwise, and we know that's a negative angle, what's the sine of negative pi over 4? Well, it's in quadrant 4. The sine ratio represents the y value. We know that's negative square root of 2 over 2. Okay, so if I line this up, if I say the sine of negative pi over 4 equals, well, I have to adjust the positive version of the angle, sine of pi over 4, by negative 1 so that it's true. Let's take a look. Sine of negative pi over 4 we said is negative square root of 2 over 2 equals negative 1 times what sine of pi over 4? Square root of 2 over 2. So negative square root of 2 over 2 equals negative square root of 2 over 2. Therefore, we can conclude that sine of negative theta equals negative sine of positive theta. Okay, so that's a very important identity right there. That's the first one. Folks, the cosine version. Draw another graph. Call this theta. Theta equals pi over 4. Let's use the same one. What's the cosine of pi over 4? That equals square root of 2 over 2. Let's do theta the other way, where theta equals negative pi over 4. What's the cosine of negative pi over 4, folks? That's cosine of negative pi over 4. I'm still going to the right, my x value. That's still square root of 2 over 2. So what does that tell me? Cosine of negative pi over 4 equals cosine of pi over 4. Well, we know that because square root of 2 over 2 equals square root of 2 over 2. So therefore, in general terms, cosine of negative theta equals cosine of theta. Okay? And that's our second one. Let's look at why does sine of negative theta equals negative sine of theta. Well, if I look at it from a transformation standpoint, I know that's the b value that I'm adjusting, right? And then on the right side, that's the a value. Well, what does this b value tell you? B equals negative 1 in this case. That is a reflection in the, well, b value, y-axis. What about this a value? We said sine of negative theta equals negative sine of theta. Well, that is a equals negative 1. That's a reflection in the x-axis. So you're telling me you take y equals sine of theta, our base function, and I reflect it in the y-axis, so b equals negative 1, and then I reflect it in the x-axis, a equals negative 1, I'll have the same graph? You sure will. Okay, and we'll see in a Desmos explainer on how that works, so you can visually see it happen. Okay, and then let me do the cosine version. So y does cosine of negative theta. Why does that equal just cosine of theta? So again, cosine of b theta, b equals -1. That is a reflection in the y-axis. So we're using the y-axis as the mirror line reflecting cosine. Remember, we're cosine our base function. This is just the base function with no transformations. This is our base function. So you're telling me you reflect the base function y equals cosine of theta in the y-axis, and you still get the same thing as the base function. So if you visualize what a cosine function looks like on a graph where it starts at 0, 1, and you reflect it on the mirror line y on the y-axis, which is the mirror line, you'll get the same graph. And again, we'll see in a Desmos explainer how that works. Okay, so we're on Desmos, and I'm going to start with the graph y equals sine of x, and there's our standard y equals sine of x base function. And what are we doing here? Y equals sine of negative x, so we'll reflect the sine function in the in the y-axis. And then we're showing here, I'm going to throw a negative a value in front, and what happens? It lines up the two graphs. So this graphically shows that y equals sine of negative x equals y equals negative sine of x. Next one, I have y equals cosine of x, our base function. Let's turn it on in purple. And you can see that y equals cosine of b of x. Let's turn that b value into -1. So let's reflect it across the y-axis. And what happens? The two graphs line up.